Today we will see the effect of two successive stimuli of same strength on a simple muscle contraction of gastrocnemius muscle. So lastly, on the previous class, we learned about effect of multiple stimuli on a simple muscle curve. Okay. Now, in this experiment, we will study effect of two successive stimuli, giving one after another. Okay. Today's objective, we will learn about absolute and relative refractory period. We have learned that beneficial effect and contraction remainder on this previous experiment. So our aim today is to study effect of two successive stimuli on a skeletal muscle contraction. So this is the theory part. We'll come in later, okay? When two successive stimuli, either it be maximal or supramaximal, when applied to a skeletal muscle, the response to the second stimulus depends upon how soon it has been given after the first stimuli. Since the contractile machinery doesn't have a refractory period, the effects in response to two successive stimuli can be added up. This is the summation effect. So, this is a simple muscle twitch of a skeletal muscle. So, on today's experiment, we will see what if the second stimuli, if we give in the first half of latent period or in the second part of latent period, in the contraction period or in the relaxation period or after the completion of relaxation. So this is the diagram which you have in your book also, okay? So what happened? So suppose this is the first stimuli, okay? So first stimuli, this is the latent period from P1, point of stimulus, P1 to the initiation of contraction. So this is the latent period. You remember now, latent period? So this is the latent period. After that, this is the phase of yes. This is a phase of contraction and phase of relaxation. So what happened? Previously we have given repeated stimuli. Okay, but in this experiment, what we will do is we will give two successive stimuli depending upon the site. Either it will be in the first half of latent period or later 1/3 of the latent period. So this is the second stimulus, okay? If first stimulus is this, so second stimulus is this one, okay? So if second stimulus is given in the first half of the latent period, what will happen? There will be no change in the magnitude or change in contraction, height of the contraction, okay? This is so because in the first latent period, either it may be maximal or supramaximal, there will be no effect, okay? There will be no effect. But if we give stimulus in the latter half of the latent period, what we will see is there is an increase in height of the contraction, okay? If we compare this one with this one, there is increase. So this is called beneficial effect. The first stimuli is beneficial to the second one. So this is called beneficial effect. So similar way, what if we give second stimuli in the contraction phase? So what will happen? There will be decrease in latent period first. There will be decrease in latent period and then there will be increase in height of contraction. Now, what you will see in this graph? This stimulus is given in the relaxation phase, but it was not relaxed properly. So before relaxation, another stimuli was given, which resulting in summation. So it resulting in increased height of contraction for the second stimuli. So suppose this is the point of stimuli, we have given stimuli, then again here we have given another stimuli. So what happened? In resultant there is an increase. So this is beneficial effect. Previously in a class it has been shown what is beneficial effect. Okay. And then if the second stimuli is given after the relaxation phase. So this is completely relaxed, and then there is another, this one is, there is an increase in height. So how we will give to successive stimuli? So basically the preparation on your previous experiment, this one is all near about same, but here we will be using 2 striker. Suppose, can you give me one copy? Suppose, so if this is a drum, we will having 2 striker. Okay, 2 striker. So one complete revolution, there will be 2 phases of stimuli. Now these striker are made so that they are, one is variable, one is constant and one is variable. Suppose if the drum rotates after one complete revolution, so there will be, we will get two stimuli. Okay, so the 2 strikers are adjusted so that the second stimuli either it should be fall in the first half of latent period. So in first half of latent period, what will there, the 2 striker will be close to each other, and then on the repeated we will like adjust accordingly. Okay, suppose this is a muscle twitch. Suppose this is a muscle twitch. So from point of stimuli to the point of এই যে লেটেন্ট পিরিয়ড, এই লেটেন্ট পিরিয়ডটাকে 2 ভাগে ভাগ করা হয়েছে। ফার্স্ট হাফের মধ্যে যদি আমরা স্টিমুলাই দিই তাহলে আমরা কিছু পাচ্ছি না। কেন? বিকজ সোডিয়াম চ্যানেলস আর গেটিং ইনফ্লাক্স ভেরি রেপিডলি. It is not giving any time to conduct any other stimuli.
Here's experiments on amphibian skeletal muscle. Why? To demonstrate some properties of the skeletal muscle. Okay, like summation is one of the property of the skeletal muscle. All on non-law is one of the property of this skeletal muscle. Contractility is another. Refractory period also there. Conductivity is also there. So these are the properties we learned. Some properties we learned from the amphibian experiment, amphibian skeletal muscle experiment. From today's lecture, now we will be performing, in the coming days we will be performing various amphibian heart experiment. These heart experiment are based on properties of the heart. What are the properties of the heart? Can you tell me one? Any one property of the heart?
Auto-excitability.
Okay. One is excitability, auto-rhythmicity, conductivity, following, all or non-low, refractory period. So these are some staircase phenomena. So these are some properties of the heart. So here also, by doing this experiment, amphibian heart experiment, we will be learning some properties of the heart. We will be able to demonstrate those properties. This is the purpose. I will ask why we are going to perform this amphibian heart experiment. Why? What is the reason? So just I told the reasons. Okay. Now let us amphibian heart. How many chambers they are having? 3 or 4? 3. What are these? 2 atria, 1 ventricle. And another Cavity-like structure is also there. This is called sinus venosus. Okay. While taking the tracing of heartbeat of amphibian heart, we'll find different components of the cardiogram. The tracing we obtain from the heartbeat of the amphibia, we call it cardiogram, not electrocardiogram. This is cardio. We are demonstrating in cardiogram, we demonstrate the mechanical activity of the heart, not the electrical activity. ECG, we record that is the electrical activity of the heart. So here we are recording the mechanical activity of the heart. So these are the properties of heart. Some properties of the heart, and out of this, some properties we will demonstrate through different experiments. This is amphibian heart circulation. So we can see there are 2 auricles and 1 ventricle. So at the back there is sinus venosus. So this is sinus venosus. Now we can see which one is sinus venosus, and the node that generate cardiac impulse by the amphibian heart is located in sinus venosus, not in right atrium, in sinus venosus. Okay, so the top 2 one, that is the left atrium, that is right atrium, and this is ventricle. It has been shown. So same thing. Now for experiment, we have to take a frog and we have to make it unconscious. How? The spinal cord will be destroyed by pithing that we have seen in at the beginning of the skeletal muscle. We have make the frog unconscious by pithing, destroying the spinal cord and destroying the brain. But here we will not destroy the brain, only we will destroy the spinal cord, because we may do some experiment with vagus nerve. Vagus nerve is a cranial nerve, originates from the brain. So, and that doesn't go through spinal cord. Okay, so that's why we kept the brain intact. If you want to demonstrate the activity of the vagus nerve on heart, so that's why we kept the brain intact. So, what we did after pithing, make it unconscious, what we did? Dissect it and open the heart. The heart is contained within the pericardium, so we opened dissected the pericardium and opened the heart. Now we will see the heart is beating. And what we will do, we will lift the heart vertically at 90-degree angle. Then we will fix the base of the heart. This will lie on a myograph. The myograph is having paraffin, solid paraffin coating. So we can, by pin, we can fix the base of the heart to the board. Okay, then previously it was like this, it was beating like this. So I made it like this. Okay, then this is the thing. So I have base of the heart is pinned, and this is the tip, apex of the ventricle. Now I will take a hook, and one end of that hook I will insert through the apex of the heart, and another end of the hook will be a thread. Okay, so suppose this is the hook and there will be a thread. That is the hook. That is the hook. And I will attach the thread with this lever. This lever is called Starling's heart lever. Starling's heart lever. So I will fix the thread with this with this, so that the beating of the heart, when the heart will be beating, there will be up and down of the stylus. And this will be moving like this. And this movement can be recorded on a kymograph. So this is the thread connected with this. So now with the beating of this, there will be movement of the stylus. So this is the recording drum. Other day I explained how a smoked paper can be smoked and fixed to the kymographic drum. So this is the paper is smoked and fixed with the kymographs. Then we made adjustment. So this is the stylus and this is the graph. Here I will attach, and after that we can have a recording. The beating of the heart, we will get this type of recording. If we take the recording, kymograph can be moved very slowly. The drum kymograph has different speeds. Like means there having a regulator. So with the regulator you can increase, decrease the fan speed. Like that you can increase, decrease the movement of the drum. So at slow speed, if you record the cardiogram of the heart, then different component of the beat can be recorded. If it is moved, if the drum moves fast, then different component you cannot identify. Now these are the different components of the cardiogram. These components, this upward stroke, it is due to systole of the sinus. The sinus is also having myocardium. So that will also contract, relax. So contraction of the sinus, this will be the contraction of the sinus, and this is the relaxation of the sinus, and this is the contraction of the auricle and relaxation of the auricle, and this is the contraction of the ventricle, and this is the relaxation of the ventricle. Okay, so what is there at the bottom? What is there? Sinus, contraction and relaxation. Then the middle one, atrial contraction and relaxation, and the bigger one, upward stroke, is ventricular contraction, and downward stroke is, and this recording can be made if the drum speed is at low level. Okay. If you perform this, you may not get all these components. What you will be getting? Not sinus, other than sinus, contraction, relaxation. You will get only atrial contraction and relaxation. Okay. So, usual recording, this is the usual recording. So, usual recording, what you are getting? No sinus systole, no sinus diastole. Only auricular systole is there, and auricular diastole is there, ventricular systole is there. So it needs, if you want to record, it can be demonstrated if you take all the precautions. If you take longer time to paralyze the animal, to paralyze this thing, and if you are unable to, your ringer lactate solution is required, so that heart doesn't dry. So that's why after some time you have to apply ringer. That is the amphibian saline. Okay. So normally you will get this. So what is that? It is the upper one, the actual, normal, and it is the B1 is usual. Now we will be studying, we are in a position, so normal electrocardiogram we got. Now we can perform various experiments to see the effect of, to see the effect of various effect of different drugs or different external factors on the normal heart rate, normal force of contraction. See, two things are evident from this tracing. One is the heart rate. So you can record the time. So if you have the time and also number of beats, with that you can determine the number of heartbeats in a particular time period. That means you can determine the heart rate. And from the amplitude, you can assess the contractility. You can assess the contractility of the heart muscle. So these waves are because of contraction of the atrial or ventricular muscles. So it is demonstrating the contractility of the muscles. And automaticity, rhythmicity is also demonstrated by these heartbeats. See, all the beats are at a distance, similar distance. The gap is same. That is rhythmic. The other beats are rhythmic. Where from this stimulation is coming? SA node. Where it is located? In case of sinus venosus. Okay. So now we'll see what is the effect of hot and cold saline on the cardiac muscle. In skeletal muscle, what you have observed? When you applied hot saline, what you have observed? What increased? You have what is the changes in latent period? Reduction in latent period means conduction velocity has increased. This was the effect on nerve. And what was the effect on directly on the muscle?
Increased contraction.
Why? What are the reason of increased contraction? What are the reasons? You don't tell. Hello, you. What are the reasons of increased contraction?
Increased amount of calcium.
Why the amplitude is increased? But with amplitude is increased, contraction period is decreased, relaxation period is decreased, and with height is increased. But opposite effect we have seen with cold saline. Here ki latent period increased means conduction velocity decreased, and contraction period is increased, height is decreased, relaxation period is also increased. But what are the causes? What are the reason behind? Bolo.
So in heat saline, in hot saline, the temperature is increasing, so the viscosity will decrease.
Is this the only reason?
So ATP will also increase due to the increased metabolic and enzymatic pathway. So excess energy is there for higher contractions. But in cold saline,
Yeah, good. Good, very good. Temperature increases the activity of the enzymes. So there are so many enzymes operating in the muscles. For genesis of ATP, there are different paths. And these paths different steps are regulated by the enzymes, done by the enzymes, action of the enzymes. So all these enzymes activity will be increased. As a result, rate of reactions of the pathway increase, rate of production of ATP will be increased. Okay, and there is additional effect. What is that? It decreases the temperature, decreases the viscosity. See, water is water. Compare water with milk. Which is more viscous? Milk is more viscous. Similarly, water and sarcoplasm. Which is more viscous? Within the sarcoplasm, there are proteins also, actin, myosins. They are also there. So these has, not only these, there are other proteins. This has increased the viscosity of the muscle. Now, if I add hot saline, what will happen? This viscosity will be reduced. And viscosity is resistance. to muscle contraction. So viscosity, if viscosity is decreased, the resistance will be less. As a result, the power of contraction will be more. More force can be generated. That's why height is increased. These are the causes. Here also, you can apply those things. Here also, you can see when hot saline, now the upper one. Normal tracing, hot saline is applied on the heart. Now what you can see, height is increased, force of contraction is decreased. Reason same. Here also it is muscle. So here also viscosity will be reduced as a result, and temperature, because of temperature, increasing temperature, there will be increasing activity of the enzymes. So more ATP will be generated. With that ATP, it can generate more forces. Same. Then another thing is not shown here. That is not shown. That was not demonstrated. This is not an ideal one. Whenever you will be applying the hot saline, height of contraction will be increased and at the same time, heartbeat also will be increased. Why heartbeat will be increased? Because temperature increases excitability. It helps in opening up sodium channels. Now more entry of sodium will take place more faster. As a result, there will be increase in excitability of the SA node. As a result, it will increase the rate of the heart, beating of the heart. Okay, so because of this, there will be because of increased excitability of the SA node, and there will be not only increased activity of the SA node. We know there are also branches. What branches? There are also tracts that will carry impulses, carrying impulse from SA node to AV node to other ventricular muscles. We know if we increase the temperature, conductivity is increased. So because of increased conductivity, increased excitability, decreased viscosity, rate, force of contraction is increased. So what will be your observation when you apply hot saline? What will be your observation? What will be observation? Two things. Two observations you will get. One is there will be that are the viscosity is the reason. But what you observe here? Observation. One is rate increase in heartbeat, increased rate of beating means heart rate will be increased. That is and the force of contraction will be increased. Height of contraction is increased. That is, its contractility is increased, its excitability and rhythmicity is also increased. So by this we could demonstrate what? Some properties of the heart, contractility property of the heart muscle, and automaticity, rhythmicity of the heart. Okay, so these sort of properties can be demonstrated through this experiment. Now what happens when we apply cold saline? When cold saline is applied, rate of heartbeat production is decreased and force of contraction is also decreased. So these are the effects when we apply hot and cold saline on heart muscle. This is the beating at room temperature. Now temperature brought to 25 degrees centigrade and see the rate is increased to some extent. Again the temperature of the Ringer solution is increased and you see the height of contraction is further increased, rate also increased. Again here you are bringing down the temperature of the heart by applying cold saline. As a result, what happens? Force of contraction reduced and rate is also decreased. Okay. Can you explain the phenomena? Now, what are the reasons? What are your observations? Fine. Again, I planned for a new experiment to see what is the effect of adrenaline on heart muscle, on heart, amphibian heart, and what is the effect of acetylcholine on amphibian heart. Now we know sympathetic nerve endings. We have sympathetic nervous system, parasympathetic nervous system, and they secrete, usually the sympathetic nerves secrete adrenaline or noradrenaline from their nerve endings. আর যদি আমি কেটে দিই কি হবে? হার্টবিট বেড়ে যাবে। কেন? তার নর্মালি ইনহিবিশনটা উইথড্র হয়ে যাবে, টোনটা উইথড্র হয়ে যাবে। আর যদি ভ্যাগাসকে বারবার স্টিমুলি দিই, রিডাকশন হবে, force of contraction will be reduced and rate will also be reduced at particular. If I continue, heart will be stopped. And again, so one thing I explained in my theory class, the heart muscles are having one property, that is TREPI, staircase phenomena. Can you remember? No. Staircase phenomena. Staircase means gradual. What is the stair? Gradual increase in height. If you make a heart quiescent means silent, means it will not be beating. So here, by stimulating the vagus, you can stop the heart, means you can make the heart quiescent. Now you withdraw the stimulation. Withdraw the stimulation. What you will see? Again, the heart will start to beat. First is height will be less and rate will be also raised. Again, the second contraction will be higher with higher force of contraction. Third one will also high, and gradually height will be increased. Staircase phenomena. This is also called TREPI. Okay, so this is another property of the heart. This can also be demonstrated in this experiment. So what we have learned today? How to prepare for, I want to study the normal heart tracing, how to record this, how to prepare. So how you will prepare? You will take a frog and destroy its spinal cord. You will be keeping the brain intact. Why? If you want to study the effect of vagus, so brain has to be kept intact. That's why. Okay. Then what you will be doing? Opening the heart. Take out the heart out of the pericardium. Then you fix the heart, the base of the heart with the myograph. Then take the tip of the heart. You take a hook. Then you hook the apex of the. You can say, sir, your ventricle may be punctured. But you know, ventricular wall is very thick. Okay, so suppose this is the ventricle. If you inside the hook, your chamber is much below. So chamber is, if you pierce the heart very low, then it may pierce the ventricle, the cavity. So it will not be, it will remain intact. The ventricular cavity will remain intact. Then you have to attach this. Other end of the hook is having thread. Now you will be attaching this thread to a lever. What is this lever called? Starling's heart lever. I have shown it. Starling heart lever. This is the hook, this is the thread, and attaches with the Starling heart lever. When I attached it, fixed it, then what will happen? It will be contracting. and there will be up and down movement of the stylus. So I can record this up and down movement on the chemograph. When I will be recording this chemograph, I will be having this sort of graph. This graph is called cardiogram. Is it the electrical activity or the mechanical activity? Mechanical activity. Contraction, relaxation, these are mechanical activity. Upward movement is always contraction. Downward movement is relaxation. So the first one, sinus, systole, sinus, diastole. The second one, systole, atrial diastole. Third one, ventricular, systole, ventricular diastole. So with this, if you take a time tracing below this, you can take it, called chronometer. One equipment is there called chronometer. So if you, it will be ticking like this. In 1 minute, there will be 60 strokes. So it can be traced on this graph. Okay, so this much distance is 1 minute. It will say this time tracing, from this time tracing, you know, this much distance in 1 minute. In 1 minute, how many beats are there? So that will provide you rate of the heart. So in usual tracing, you may miss sinus, systole, and sinus diastole. Effect of temperature. If you apply hot saline, hot ringer, what will be the effect? Rate will be increased, heart rate will be increased, and force of contraction will be increased. What is the reason?